This is section 2.2 on graphing. Okay, so we have 5 to 27 odd and 33 to 67 odd. So we'll show that to you now. Page 203 is where it starts. Okay, so 5 through 21. Hopefully you can see most of that. Of course, those of you that have the book, just look in the book. If you can't read it, 19 says 1 plus radical x. 21, c of t is 1 over t squared. And let's see, we don't have to look at the evens. Okay. Having the same light issues over there. Okay, we don't have to do these here. So 33. 33 up to 39-ish. Okay, I think you can kind of see that. Let me move that over in case my image is in the way. There you go. Next page, we have to go up to 67. So get this thing focused here. Now, move it over. I know there's that shadow in the middle, but hopefully you can still see it good enough. And how high do we have to go? 67. Yeah, sorry, it's the best I can do. I'm up against the arm here. Okay, 61, 2x minus 4y squared equals 3. 63, 2xy minus 5y squared equals 4. 65, 2 absolute value of x plus y equals 0. 67, x equals y cubed. Okay, so sorry, but that's the best I can do. Whenever we get near the bottom of the book, I have to hold the book up and it touches the arm of the document camera. So it's the best we can do. Okay, and yes, and I know there's this shadow in the middle, but I'll try to get around it. Okay, f of x equals x plus 2, graph it. Slope is 1, y-intercept is 2, m is 1, b is 2. There's 0, 2. Slope is 1 over 1, up 1, so it goes like that. Negative x plus 1 squared. Okay, so I know this is x squared. Negative x squared goes like that. And then negative x plus 1 squared, shift the graph 1 to the left. So it ends up looking like that. Cube root of negative x, I just made a little table here from negative 8, negative 1, 0, 1, 8. Why I picked these numbers because they're nice cube roots. So negative 8 gives me negative 8, which is 8. Cube root of 8 is 2. Plug in negative 1. The negative of negative 1 is 1. Cube root of 1 is 1. Cube root of 0 is 0. Cube root of negative 1 is negative 1. Plug in 8. Cube root of negative 8 is negative 2. So it looks something like that. 21. C of t is 1 over t squared. You're not allowed to plug in 0. If I plug in plus or minus 1, I get the same thing, 1. Plus or minus 2, I get 1/4. Plus or minus a half, I get 4. So it ends up looking something like that. Absolute value of x plus x. Let me move it out of the shadow if possible. So I made a table from negative 2 to 2. If I plug in negative 2, absolute value of negative 2 is 2, plus a negative 2 is 0. Plug in negative 1, absolute value of negative 1 is 1, plus negative 1 is also 0. 0 gives me 0. 1 plus 1 is 2. 2 plus 2 is 4. So here it's stuck at 0, and then it shoots up like so. Piecewise defined function, f of x is 3. That's a linear horizontal line, constant function. X is less than 2 for 3. Greater than or, let's see, greater than or equal to 2. So the slope is 1. And if I plug in 2, I get 1. That should be a closed circle there. So let me just close it up right now. It's greater than or equal to 2. 39. These are constant functions. So constantly negative 1 if x is less than 1, negative 1, not counting negative 1. So horizontal line there. It jumps up to 1 between -1 and 1, including -1 and 1. So closed circle, and then jumps down to -1 for x greater than 1. Open circle, close, close, open, open. 45, f of x is 4 if x is less than 2. So constantly 4. X squared between -2 and 2 inclusive. If I plug in -2, I get 4. That closes up that circle. And 2, 4 also here. I know it's parabolic. Goes like this. Then for x greater than 2, y is -x plus 6. If I plug in 2, I get 4. Slope is -1. So it goes down like that. So this thing is continuous all the way through. 49, f of x is -2 if x is less than 2. So open circle, constantly -2. Then x between -2 and 2, slope is 1. Y-intercept is 0. So it goes like so. And then x greater than 2, it's constantly 2. So if I graphed only this part, it'd be an open circle, but it gets closed up from here. So again, this function is always continuous. Okay, functions pass the vertical line test. So 51a is a function. If I draw a vertical line anywhere, it'll touch at only one point at the most. So yes, that's a function. B is not a function. I can draw a vertical line which touches 2 points. C is a function. If I draw a vertical line anywhere, it's not going to touch at 2 points. D is not a function. It'll touch at 2 points. 53 asks for the domain and range. By the way, it is a function. It does pass the vertical line test. Domain is -3, 2. The range is -2, 2, both bracketed because I go from -3, including -3, to 2, including 2. And for the range, I include the -2 and I include the +2. 57, is it a function? Can I solve for y? This one, yes, a little bit of algebra. Move over the 5y, subtract 7, and divide by 5. Y is 3/5 x minus 7/5. That is going to be a function. We know that. 59, x equals y squared is not a function because that means y is plus or minus radical x. So if you give me a value of x like 4, y could be plus or minus 2. That violates the idea of 1x giving me only 1y for a function. So no, that is not a function. 63, I claim is not a function. If x equals some value, you can kind of tell for some values of x, to solve for y, you'll have to use a quadratic formula, which means there's going to be 2 y values, right? So if x is some number, 10 or 50 or 25, okay, to solve for y, you would have to use a quadratic formula, which in general, you would have 2 solutions. So the answer to that is no. 67, can I solve for y? Yes, take the cube root of both sides. You have y equals cube root of x. Y is isolated in terms of x. So 63 is a function. Right, so these are some problems from section 2.2.